Hi. Welcome to week 4. If you're watching this, like whether it's live or recorded, you've probably submitted your first assignment. So congrats to everyone for submitting your first assignment. If you haven't submitted your first assignment by the time this lecture is being recorded, I guess you have, I don't know, a little bit longer to submit it because it was due 32 hours ago. So probably got a little bit longer, but most people have submitted by now. What are we doing today, right? Because you're all probably tired, you're all probably fatigued. Let me get to the point with it. So the purpose of today's lecture, the week 4 live lecture, is to run through assignment 2. Now, there's not really any slides for this today because it's mainly going to be like a let's go through the spec together, let's do a little bit of a demo setup. So it's kind of like what we did with assignment 1, right? Where we kind of gave you a brief on it. The difference is this time that it's a little bit harder because it's a second assignment, so there's a little bit more to it, and therefore there's a little bit more to talk through as well. So where do you find your assignment 2? Well, it should be on the assignments page itself. It was released a week ago, right? Which is good news, because some of you have started, and I've seen people on the forum starting it. And again, I think that's good because sometimes students say they feel crunched during mid flex week. So there's some students trying to get everything done before flex week and take some time off. I wouldn't be one of those students because I was a terrible student for most of my degree, except for the last term, really. So I admire those who've done that. Now, last point of housekeeping here is that my MBN connection got delayed, which was really upsetting because I was really looking forward to it. So it'll be connected in a week, like 2 weeks or something. Thursday week, so mid. I don't know. It's next week. I don't know. Next week, next Thursday. That's a little bit annoying because I know we sometimes have stream instability, generally around 7. But again, at least the problem's going to be solved. So there's some good news. Now, in terms of assignment 2, like assignment 1, you how would you put it? Like, you have your own repo for it, just like assignment 1. Sorry. So for assignment 2, you have your own repo, just like assignment 1. Now, what exactly is assignment 2? Well, it is a JavaScript-based assignment, and I'm just going to pull up a copy of it here. Assignment 2 was written by Emily mainly, and there's me and Emily, but Emily mainly. And what it is, and at a high level, and we'll read through this together, is it's a front end for a Slack style application. So if anyone's used Microsoft Teams, if anyone's used Discord, if anyone's used Slack, they're all the same thing. They're kind of these instant messaging applications. And you're going to be building a front end for one of these instant messaging applications. So the back end's already built for you. That's the assignment in essence, is that you've got a back end and the front end's already built for you. Now, what's particularly interesting about this assignment is that when Emily and I were talking about what we wanted this assignment to be and what we wanted to consist of, we spitballed a lot of different ideas, and what we ended up coming back to is we said, hey, well, we liked what we did in 1531, so maybe we should do that, but the other way around. So there's about 300 students in this course, and about 200 of you are students who've probably done COMP6080 with me, just statistically. So the majority of people in this course, have probably done a 1531 comms-based assignment with us. So if you haven't, if you're a postgrad student, or if you're a credit transfer undergrad, or if you're an undergrad who's older and you haven't done this, don't really worry. Because if you didn't do 1531 with me, it's not going to make any difference. It just so happens that it's coincidentally a very similar kind of thing. So you think about an application like Slack, Microsoft Teams, Discord. Naturally, these applications have some kind of server, and a server's, most code you've written at uni is kind of server-ish. And these applications also have a front end, which you can kind of picture because we're a few weeks into the course now, and you can think, okay, well, a front end's a whole bunch of CSS, HTML, and JavaScript written to be run on a web browser. So you're building a front end. So if we have a look at this assignment, we kind of read through some of the fluff text up the top. Web-based applications, blah, 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 blah. You can read this. This assignment consists of building a front end with vanilla JavaScript. So this is basically a front end that's using plain old built-in JavaScript, like we used in the lecture last week, like has been used in some of the tutorial questions this week. This is not an assignment on React.js or any of those topics that we've been discussing. So it's all vanilla JS front end. That's essentially what you're doing. The front end and the back end will be talking via a RESTful API. Basically, you know, an API that has get, put, post, delete requests that communicate between the front end and the back end. And that back end is written in a Node.js Express server, which I briefly demoed for you in week 2, I believe. But it's already written for you. You don't have to touch that at all. There's nothing you need to worry about. Now, in terms of the skills you need to do this assignment, again, you kind of have most of the skills necessary up to this point, in the sense that this assignment is really just a lot of HTML, CSS, and JavaScript fundamentally, which we've already talked about. The only fundamental knowledge that you need to bring into your repertoire since the last time we talked are these week 4 topics on events, XHR, promises, and fetch. Now, these lectures are a little bit more theoretical in reality, so if you don't fully get all the theoretical components, that's totally okay. But essentially, these lectures are on how does asynchronicity work in JavaScript, and how does a network request fetch work in the context of JavaScript. That's the crux of what those lectures are on. Now, for the sake of today, I'm going to assume that you have probably watched them. I don't want to say I'm going to assume that you get everything perfectly, but if you've kind of seen them, then you're in a good stead. If you haven't, you could obviously stop now and go watch them first. If you haven't watched them at all, you're probably still going to be able to make sense of a lot of things today. I'm just not going to answer a bunch of questions that I think might be covered in that lecture, right? Just for efficiency. So let's keep looking at the spec. The web-based application you build, as in the front end you build, will be what we call a single-page app, or an SPA. Single-page apps give websites an app-like feeling, and they're characterized by the use of a single full load of an initial HTML page, and then using AJAX or fetch and other DOM manipulations to dynamically manipulate the DOM without ever requiring a full reload. Now it's like, okay, well, what is that? Now, we have lectures, I believe, on single-page applications in week 5. However, this is specific to React, right? This is very much like a React thing. It's probably worth looking at, but to be honest with you, single-page applications is like a concept. You know, there's not a lot to it. It's very straightforward. It's like saying good style. Like you can really spend a lot of time on it, but to understand it, you're like, that's what good style is. So I'll briefly kind of explain at a high level what a single page application is, because that's really critical to understanding assignment 2. But we will come back to that. That's all that paragraph really says. Okay, so that's the intro. Building a front end, you need to understand promises and fetch. It's going to be a single page app, and everything else you already know today, right? So that's all pretty doable. We'll talk more about SPAs when we come to do the bit of a demo. Okay, so what's the task you're doing? You're going to build a front end for a UNSW ripoff version of a popular messaging tool, Slack. So you're just building a front end for that. If you haven't used Slack or Discord or Teams, I'd strongly recommend you download it and play around with one of them. Most of you would have, in my experience, in some way. Like the 98+% of you would have. So this is just a comment for those who haven't. Yeah, you can just download it and play around with it. You only have to build the front end. And in terms of the spec, in terms of the things we ask of you, we actually give you a set of requirements as to how your front end needs to be or what it needs to look like. But they're kind of vague. And That's actually a good thing, because I know students in general, you'll see something that's not overly prescribed and you'll panic. But the thing is, in assessment generally, vagueness is good, because vagueness is fun. It gives you room to grow. It gives you room to try things out, to be creative, which is the whole point of education, right? Is to be curious and creative. The only time vagueness is bad is when what we ask of you is vague, but what we mark of you is quite strict and quite defined. But in this case here, we're going to be marking you very vaguely as well, in terms of like the degree to which we mark whether you've done things correctly or not is going to be as much as we ask of you. And what I mean by that is, if we actually have a look here at what the task is, at what you're actually doing in this assignment, there's a whole bunch of text right here which describes what and how your front end is. Think of these like a list of requirements. And these are the literal things that we will be going through when we mark it. So like, for example, like let's have a quick look at this. And again, I'm going to assume if you're listening to this right now, you understand what a basic Slack application is. It's like, we want you to build some kind of login capability. When a user isn't logged in, the site gives them some kind of login form that contains an email, a password, and a submit button. When the submit button's pressed, the form's sent to this route to verify the credentials. If there's an error during the login, an appropriate error message appears on the screen. That's what we expect you to do for some kind of a login to this Slack application. Now, again, you might be asking, how big's the form need to be? Does this need to be a pop-up or a full screen thing? Or, do they need to confirm their password? Should the submit button be at the top? If we don't specify, we don't care, right? Like when the tutors mark this, I've written the marking criteria. We literally say like, has a login section, has email field, has password field, has a submit button. Submit button, logs you in. Incorrect details give error. Like that's what we give the tutors, and they check that off like a checklist, right? So the reason I just want to be really clear about that up front is because, don't be alarmed by it. It's actually a good thing. It's what we want to do, because this is kind of one of the funner parts of the course, right? Is that you actually get to go and build something that might be different to what everyone else has in the course, often in very minor, insignificant, irrelevant ways, but you get to have a little bit of creativity and make life a little bit more fun than it certainly can be sometimes. So we expect you to build something that a front-end thing that allows users to log in. We expect you to build a front-end thing that allows users to register or sign up. We expect you to have some kind of error pop-up that comes up when something goes wrong. So if there's errors, then you get a pop-up. This is all part of what we call milestone 1. So the assignment itself is broken up into a series of milestones, which realistically don't mean anything. It's a little bit like grades, right? It's like grades with your marks, like HD distinction. Like, they mean nothing. They're just ways of slicing off marks into sections. It's like, is a person who got a 76 and a person who got a 74 that different? No, they're 2 marks apart. We're just drawing some lines somewhere. So we've done the same thing here in terms of the specification, in terms of, we just say, this is milestone 1. We could have made it smaller, bigger. There is no marks. Like, we say it's worth 15%, but if we put more into it, it'd be worth more and it'd be worth less. We could just give you a list of 30 things to do, but instead we just wanted to break it up into categories, so it's a little bit easier for you to kind of be like, okay, I've done this big chunk, I've done this big chunk, I've done this big chunk. So they're there for vanity and for structure. They don't have any bearing on your existence, really. So you got your register login stuff. The next thing is like creating and viewing a channel, right? So in any kind of Slack, Teams, Discord application, you got to create some kind of channel, so we want you to build a part of a front end that allows you to view a list of all the channels that exist. We want you to build something on the front end that allows you to create a new channel. We want you to build something that allows you to view and edit the details of a particular channel. So, you've got a list of channels, you can create more, you can click on a channel and see the details of it. That's what that section's about. Why do you have channels in these applications? It's so you can share messages. So the third milestone is about messages in a channel, right? You want to be able to view all the messages in a channel, like Microsoft Teams and stuff. You want to be able to view them in chunks, right? Like standard pagination. You want to be able to send messages, delete messages, edit messages, react to messages, pin messages, all the kind of standard things you might do with a standard application. This kind of goes on. I won't dictate all of it because you can all read, I believe. Inviting users to channels, seeing a profile, viewing and editing your own profile, sending a photo in a channel, viewing a photo in a channel, and then things get a little bit harder after that. So like milestone 6 worth 5%. So milestone 6 and 7 are very much into like the upper end of the HD category. So this is how we're going to try and separate out, the top 10% of the course in terms of capabilities. So again, just flagging up front. Just because it's written here, it doesn't mean everyone has to do it, right? Like not everyone gets 100% an assignment. So you're going to look at some of these things and go, this is too hard for me. And that's okay. Like that's normal. I do that every day of my life, right? So the challenge components are like infinite scroll. Instead of pagination, using push notifications with the web browser. And then the other ones are like having some offline access and fragment-based URL routing. Now, in particular, section 6, milestone 6, and milestone 7, the reason they're challenge components is because we don't actually have, I think, any lecture content on these explicitly. These are not scientific topics. These are actually just certain implementations, right? Like push notifications, infinite scrolling, offline access. You can Google these. You can watch YouTube tutorials on these. There's tons of different ways to solve these problems, blah, blah, blah. We're not here to provide assistance for you. That's kind of like an independent learning thing. And it's like, okay, well, is that fair? It's like, yeah, I mean, there's pretty much your entire life in the field of web is going to be a large degree of independent learning, right? So it's good practice for that. And again, this is designed for the upper tier students. You can still do it. I'm not saying you can't do it. Anyone here can do it. It's just like, don't get stressed about this until you feel like you've nailed everything else, because these are the last 10% of the marks, right? So don't stress about this unless you've gotten 90% of the marks. And again, these are generally speaking not always going to be very mark efficient. That depends on your skill level. Raymond says, would this be like Socket? Not really. Push notifications are web browser-based push notifications. But I mean, no, it's not like Socket. That's probably the simplest answer without causing any confusion. There is 5 marks for bonus marks too. So if you are some students that are like, yes, I've done everything, I can do everything, then we're actually happy to let you be like, I want to do some more extra stuff. And if you go do some extra stuff, then you can just go and do it. You'd be like, oh, I added this feature. Now, the tricky thing about this part is that it's like, to an extent, you kind of have to think about features that don't really require backend modification, right? So it's very hard to say, oh, I'm going to do a feature which is like sending audio messages. And it's like, that's cool, but that does require the backend to be modified because you have to store them somewhere. So some fun front-end features, like often when you think about front-end features, it can be things like presenting more information on the page, having a fun little game there, like a little text game in the chat, some more front-end valid. It's basically extra work. So like the point of the bonus marks section is so that if you just have something that you're like, this would be awesome, we want you to be able to do it and feel rewarded for doing it. The one caveat that I will say, though, about the bonus features is that they are going to be the least efficient marks for you to get per hour of work. Okay, I just want to stress this because, it's really hard to mark bonus features because it's really open-ended. But typically what I say to tutors, and I haven't said anything to them, but I'll tell you roughly what I say to them. I usually say to them, give full marks to anything a student does that would take you, a tutor who knows their stuff, maybe like 10 to 12 hours to do. That's what we say to them. So if you're like a pretty mediocre student or a bad student who spends 3 or 4 hours on something, you're probably not going to get many marks in a very general sense, right? It depends what you do. There's no certainty to that at all. But the point is that it's not a place to like get easy marks, because they're not going to be easy marks. It's a place that if you kind of feel like you're on top of everything else and you want to keep stretching your wings, we're saying we will in some way finitely reward you, right? Bonus marks tend to be very binary too. 90% of students don't bother, 10% of students really get into it. That's kind of how it sounds fine. Yeah. Diarmoid says, how about a game like the Dino game in Chrome when you're offline? I mean, yeah, something like that is, you know, something like that is good. Sounds fun. Okay, flashback to the Hangman game. Alright, well, I mean, that's kind of it on the task, right? There's a whole getting started section here that shows you how to like get it started and how to get the backend started, and we're about to do that. Though I'll that's kind of what we'll do last. In terms of constraints assumptions, you can use you can do this in ES6 JavaScript. Like that basically means you can do this in the JavaScript that we've been writing in the course. You don't need to worry about transpilation or anything. You can't use any JavaScript libraries though. This is kind of, where is this written? Yeah, you must not use directly external JavaScript. Basically, you can't import JavaScript. All the JavaScript in your project is going to be written by you. You can't use React. You can't download some other random JavaScript library. It all has to be written by you. We may make some exceptions to this if on the bonus stuff if we really need to, but it's just a blanket rule. You know, you can always ask for clarification. In terms of CSS, you can use as much external CSS as you want. You can use CSS libraries. You can use Bootstrap. You can use Material UI. This is not a CSS assignment. The first assignment was about you really getting intimate with CSS. This assignment is really about you getting really intimate with JavaScript. So CSS is not the crutch here. You can go and use libraries for that. There is a lecture on CSS libraries. I move these around every term, but where is it? Using CSS frameworks, non-React. There you go. Oh, I did this one. Great. 21H. What the hell is H? Okay. Material UI. So like Bootstrap's really common. Is there Material UI without... maybe I'm getting this mixed up, sorry, with... might be getting this mixed up with another library. I don't use Material UI for... Maybe not Material UI, but Bootstrap's pretty common. There's a few other libraries out there. There are some libraries that are specific to React and these other kinds of things. But generally Bootstrap's going to be the most common thing you want. You can go watch the lecture on it. We're not here to talk about that because otherwise you're going to watch that and be like, why am I doing this twice? But the point is you can use as much CSS as you want. You're doing things on Chrome. In terms of the JavaScript you write, pretty much the only thing we kind of ban, a couple things we ban. We ban the use of using the inner HTML DOM object property because it's dangerous and it's cheating and all this kind of stuff. And then we also prohibit the use of async and await. So you can't use async await. This will make more sense again if you have watched like more how would you put it? If you've watched like more of the Promises lectures and stuff. So if you haven't watched the Promises lectures, then you'll be like, all right, this is fun. So Lil Nalco says, can we use some of the JavaScript code that bootstraps Jess? That's a great question, and these questions again are coming from people who either know more or have looked at this more, so don't stress out if that question doesn't make sense to you right now. But essentially, a lot of these CSS libraries, they sometimes to do some actions that you can't do with CSS, they'll use a little bit of JavaScript, and in some of the code snippets they'll give you a little bit of JavaScript as well. that is okay to use. And in fact, we've written it here. Some Bootstrap functionality relies on accompanying JavaScript. You're committed to include this. Blah, blah. Basically, it's like using some JavaScript that's provided to you as part of these libraries to solve a really basic UI problem, like making a button have an effect, is okay. But again, if you're unsure, you can simply post on the forum and we'll help you out. That's really as easy as that is. Cool. You can't use await async because if you don't... okay, so again, I'm assuming that you've all watched the Promises I'm assuming you've all watched the Promises lecture. In week 5, there's a lecture on await async, which is a more modern syntax wrapper for dealing with promises. Not in every situation though. Why do we prohibit the use of async await in this assignment? The answer is twofold. One is that if you don't understand promises, then you don't have what we would consider to be the appropriate theoretical knowledge on the topic of JavaScript asynchronicity. So it's kind of like cheating, right? We want students in this assignment to demonstrate that they actually understand the theory and the science of what this is. In assignment 3, we don't prohibit it, but in assignment 2, you have to. There's a lot of JavaScript programmers out there who teach themselves await async, and they never actually learn promises. And that means they don't really get what's happening. And even more than that, the way JavaScript's designed and the way it pans out is that you actually can't avoid promises in all situations, right? So it's like you can use JavaScript promises pretty much everywhere, and then await async can be used to clean up that code in many cases, but not all cases. So you actually can't avoid it. And if you can't avoid it, we're here to educate, we're here to set learning outcomes. It's important that we feel like you've met that learning outcome. In terms of the marking criteria, 70% is on what we call compliance. Compliance is basically compliance in this case is basically, did you tick all the boxes that we asked? We asked you to do all of this. So 70% of your mark comes from your tutor using your application and quite literally just going check, 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 cross, cross, check, 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 like that. So 70% of the marks come from that. 15% of your marks come from mobile responsiveness. So about half those marks come from a tutor. So basically, tutors are going to mark your work on a desktop, right? Because it's easy. We code on laptops, we dev on laptops. So they'll mark it. They'll mark the 70% on a desktop. Then what they'll do is they'll poke around the side a bit on a tablet size, and then they'll poke around. Tablet size is just kind of like I don't have specific dimensions, and tutors aren't going to be super specific either. But the other one's the mobile size. So mobile size, we said 400 by 700. So they're going to kind of poke around your front end with that and be like, is this usable? Like, is it clear they've made sure it looks okay on this, right? It doesn't need to be brilliant, but it's very obvious as someone who is familiar with web development, whether you've given it any time or not. Web pages don't just magically look good on mobile a lot of the time. Tablet. What size is tablet? If I'm going to be honest with you, if your site looks good on mobile and it looks good on desktop, it's probably going to look fine in the middle, right? So there's no specific size there. And if, and a tutor's not just going to like pick a random size and be like, that's it. They're going to play around with it to double check. So there's nothing you need to like, stress about that. But it's pretty easy. And in fact, my recommendation to you, sorry for my half attention for that. There's been a very big emergency that I had to deal with for a second there. The thing I would recommend, honestly, is that you try and develop the site on mobile. The reason for that is because it's actually a lot easier from a coding perspective to get a site that like works on mobile, and then you just, when it gets bigger, you just maybe change a couple things. It's really hard to kind of go the other way. And part of that as well is because when you kind of code for desktop, what happens is you tend to be spoiled, right? You tend to have all this space. You have all this space to make things look good, and therefore it's like you get spoiled with all this space. And when you then go to mobile, suddenly everything's cramped, and you're like, oh god, nothing fits, and how do I make it fit, and blah blah blah. So I generally recommend you even do your development on mobile, and some things look good. Some things look good when it's just a big mobile. Like there's some websites you've probably gone to that are actually just designed for mobiles. I'm trying to think of one, but nothing jumps to my head immediately. I mean, m.facebook.com might be one of them. I don't know. This is like a mobile Facebook site. It doesn't look terrible, right? It's not quite Facebook, but it's designed for mobile. It's designed for that. But like it looks fine, right? Like it's just literally the page is bigger. So that's why I kind of recommend TikTok. But I don't think the TikTok site is actually, unless there's like a mobile TikTok. But this is clearly a desktop site. Like when I say a mobile site, obviously the site looks good on mobile, but you can see that this is like a desktop site that compresses down and then it will, they've thought about that a lot. But I'm saying like the m.facebook thing is literally just a site on Facebook and stuff. So start with, I would strongly recommend that you start with mobile. It's just going to make life easier for you. So great. 10% comes from code style. So tutors will look at your code. Is it clean? Is it well commented? Do the variables make sense? Is it easy to follow? Nothing crazy there. It's really just trying to discourage bad programming practices. We haven't really specified any like massive tenets of good JavaScript, but we have talked about in lectures and tutorials good code, bad code. I mean, if you want some help with this, I literally talked about this for like the last 25 minutes of my tutorial yesterday, which was recorded, right? So we're not going to be like crazy about code style, particularly. It's not like semicolons or anything. It's going to be very much like, does this code generally look cleanish? Like, does it make sense? Are you like an adult wrote this, not like, a stressed out first year programmer who's just trying to hack it all together and make it work? Paul says, do we have to make an effort in not having our front end look too much like Slack's? No, it doesn't matter. Look, make it look how you want it to look. You could copy Slack, you could copy Teams, you could copy this, you could do whatever. It's like, I mean, when I say copy, I don't mean like steal source code or anything, even though that wouldn't be too useful. I mean, you can just be like, I'm going to make it look like Slack. You could be like, that's my job. I'm going to make this look exactly like Slack. I wouldn't, because that sounds exhausting and I don't know what the payoff would be for you, but yeah. And then we have 5% here on usability and accessibility. Now this is going to be a much bigger component for your assignment 3. Much bigger isn't bigger, still small. This course is about the programming of front end. It's not about good UI, good UX, and accessibility. But while it's not fundamentally about that, we still think it's important to teach that. So we do actually have a few lectures on UI, UX in week 7, 8, 9. There's another one in week 4 on UI fundamentals. Jamie, one of the tutors, really great, is they're coming to actually give more UI, UX lectures, which is good. So there'll actually be like more stuff, which is helpful. And then we also have some accessibility lectures from Mike, from Canva. They're also great as well. This is worth 5%. It's really small for these really big topics. The reason it's here is because we want you to think about it. We want you to think about it enough to be like, I'm going to do a few things to make my page look nicer from what I've learned, and I'm going to do a few things to make my page look accessible from what I've learned. It's not meant to be a several-hour sinkhole. It's meant to be a light illustrative exercise in that kind of thing. So you can go watch those lectures. 5% is pretty small. Yeah. We also, do we do this accessibility.md? Where is it? Oh no, we don't even ask you to do that. The tutors will notice the UI UX stuff when they look at your page, and they'll notice the accessibility stuff when they look at your code probably, or look at the page. You know, if you feel like what you've done is a bit not obvious, then feel free to leave another markdown file in the repo, right? So like this repo has a README and a bonus. You can add another one there called accessibility if you want, or like, you know, something. You can add anything there. Don't add like essays, right? Tutor's not going to read an essay when they mark it, but you know, if you're like, oh, I did A, B, C, and I think it's really going to be hard to tell that from a tutor looking at this for like a couple minutes. So just, you know, just jot it down a couple of dot points. No harm in it. Okay, so that's the marking criteria. Don't cheat, don't share code, you get 0. If you make your code public, you'll get 0. Raymond says, can we be sued by Slack? All of your code has to stay private because it's an assignment, so you're not going to get sued if you don't break UNSW rules. The assignment's due on Monday the 25th of October. Monday the 25th of October. It's week 4, week 5, week 6, week 7. It's the Monday of week 7 at 8 p.m. So it's just after the end of your flex week. You can submit it this way, 6080 submit assignment 2. You can do that on a CSE terminal and it will submit your assignment. It'll submit the last master code you have. Please don't not run this command until 5 minutes before the deadline. Go and run. You can submit this today. Oh, I have to make sure I've set it up. But in theory, let's just say you can. In theory, you should be able to submit it today. If there's a couple of bugs that I haven't checked or something, we'll fix that. But it's like, if it's the weekend of week 4, just go submit it. You can submit it again. There's literally no harm in just submitting it once, because if it works the first time, it's going to work the next time. So don't leave it till an hour before it's due to try and submit it, right? You know, you don't hire a car and then keep it for a few weeks and then turn it on once you've had it for a few weeks. It's like, go play around with this now, because there's always a chance you've made a mistake, you've screwed something up, and you need help, which will take a day. Will help you pretty quickly, but like you don't want to deal with that pressure, and I don't want to think about you dealing with that pressure. Diarmuid says, accessibility just meaning the page is easy to use / looks okay. I'd recommend you go and watch the accessibility lectures. UI UX is about making a website look, feel, and move nicely, right? It's what makes it pleasant. Accessibility is allowing everyone to use the internet, right? It's allowing people who aren't technology literate, who have physical disabilities, who have other kinds of, you know, mental impairments or things that could possibly make their time worse. People with vision problems, right? There's just tons and tons of things. Accessibility is about making it available for everyone. That's why we have ramps, right? Like, we all understand accessibility. We have ramps for wheelchairs. Does everyone have a wheelchair? No, the ramps are there so that everyone can get up the steps. Without the ramps, most people, vast majority of people, are going to be fine getting up the steps, feeling good. But that's not the point of accessible design. Accessible design is making it inclusive for everyone. Lil Narco says, do we have to have area labels and all that for screen readers? That's something you could do on the front of accessibility for sure. Okay, we're at 6:50 now. I want to check, are there any last questions about the spec generally? Because we're going to take a break and then we're going to actually look at just section 3 getting started. We're going to clone the repo, start up the server, look at the server, do a little bit of coding on the front end. I'll give you some helping hand to get the... I'll help you get enough code to make a register request to the backend. That's the point of today. I want to give you enough that you're like, okay, I get how to do that basic thing, and I can just expand out from there. So, any last questions before the break? Otherwise, we'll just take a break and then get into it. Okay, 5, 4, 3, 2, 1. Great. All right. Cool. All right. Well, let's have a 5-minute break, and 5-ish, just before 7, we'll start up, and keep going. Should be fun. We will talk about single page app and DOM manipulation and stuff. Yeah, we're going to talk about register route and a single page app. and the register route will include promises. So I think we'll cover some of the key bases. But anyway, yep, talk soon. Hey everyone, welcome back from the break. We've got, I don't know how many people here, 30, 40 still, which is good. Let's get stuck into getting this assignment 2 started, right? Now, I know some of you have already started it. We tend to have keen beans who start assignments also come to the lectures, so I'm sorry that it might be a little bit slow for a small handful of people, but let's get started. I'm going to clone this repository. This is the course repository because I don't have my own repository as a student like you do, but you'd be cloning your own repository. You can do this locally or on the CSE. We've put a lot of effort into making this work easily locally. So as long as you have Node.js installed locally and NPM, you're going to be okay. And like I'm on a Windows machine here. I installed WSL, Windows Subsystem for Linux, and I installed Node.js as well. So I have Node on this computer, Node version. I have NPM as well. That's kind of the basis of what you need. So what I'm going to do is I'm going to git clone my repository. I'll do it inside my dev folder. I'm going to git clone assignment 2. It will clone in. And I'll go into that folder, assignment 2, and I've got some stuff here. Now, when I look at the README in section 3, getting started, I want to first focus on the backend because that's already written for you, which is super helpful. And we can just talk about it once and kind of be like, we've learned everything about it. Take us 10 minutes. Maybe not. Wilhelm says, come to think of it, should we be using Node version 12? I think, like, given the type of code you write, I think anything 12 or above is fine. Look, it's one of those things where once every third term in one assignment, a student's code doesn't work in a different... and they're like, what's wrong with it? And then the tutor's like, it doesn't work for me. Students like, it works fine. Tutor's like, what Node version are you using? And then it's like, they're like this. And it's like, oh, that's the problem. But I don't even think it's happened once yet. Actually, it might have happened just once. So I don't like to mandate versions because honestly, between the NVMs and the N programs and people's different systems and environments, I think it's more hassle than it's worth given the quite large load of stuff people have to deal with. So I think like any Node version that's somewhat freshly installed is going to be totally fine, though 12, 14 is fine. And for assignment 2, it also doesn't really matter because assignment 2 is like front end without any Node involvement. But let's talk about it. So the back end. You're prohibited from modifying the back end. Don't touch it. No work needs to be done on the back end. Why did I write that twice? I don't know. Maybe to emphasize it. Maybe because I can't write. It's provided to you simply to power your front end. Okay. The backend server exists in your individual repository. After you clone this repo, you must run yarn install in the backend directory once. So I'm going to go to the backend directory. I'm going to yarn install. For this project, we're using yarn for the package manager. You could use npm, but like we're just using yarn, so you can kind of stick to yarn. That's pretty simple. It's a very simple project, so it should yarn install very quickly. That was a pretty quick yarn install, 14 seconds. So that's installed all the packages. Now to run the server, I just run yarn start. Now remember, I'm in the backend folder, okay? Pay attention to what folder I'm in. I run that and it started up my server. Now my server is running on localhost port 5005. To view the API interface, basically like what the API of the server is, you can just navigate to this URL right here. If you just go to localhost 5005 or whatever port's being used, I believe we set the default to 5005, so if you just leave it like that, it'll be that. I don't know why it's 5005. I think I picked a random number and we just stuck with it. And it shows you all of the routes, all of the paths, all of the API endpoints that exist, register, login, logout, channel, get all the channels, create a channel, get the details of a channel, update the details of a channel, join a channel, leave a channel, invite another user to a channel, get all the users, update my profile, get a specific user, get all the messages in a channel, send a message, update a message, delete a message, pin a message, unpin a message, react to a message, unreact to a message. Like, it's all relatively straightforward conceptually, right? Like, that's one thing I think is nice about this assignment, is if you've used these kinds of applications before and you've interacted with a kind of interface like this before, it's like, oh, okay, I get what I'm dealing with at a high level, hopefully. By the way, we do have linked here on the sidebar. There are some old COMP1531 lectures. They're old, they're on the same stuff, but you can, if you really, really want to get more background on this, go and watch probably these kinds of 3 lectures here. So this is probably particular for postgrad students, because I don't know to what extent your postgrad program has prerequisites in this stuff. We don't necessarily like assume that you know it extensively, but there's some assumption about. I mean, it's all very basic, right? Like many postgrads know this stuff just because they tinker around. But if you want to kind of get more of a sense of how a backend's built, which you don't have to, you definitely don't have to for this assignment. It might just be helpful because I know some people really like to know everything that's going on. Then there's some handy lectures here, 4.2 to 4.3. So that's kind of easy. But to be honest with you, if I was someone who has like never seen any of this kind of stuff before, I would just start. I wouldn't like overthink it. And then as things don't make sense, I would just post on the forum or Google something or watch a quick little 5-minute video on it or whatever, right? Like I don't think there's ever much value in being like sitting down and reading a whole textbook or something. It's like just start and wait till you run into problems. But essentially, this backend here, this doc here, is the instruction book for how to use the server. So we have a route like auth. What's an easy one? Auth Register. And if I click on it, it tells me some information about it. It says given user details, registers the user, and then returns an authorized access token for making subsequent calls. So when you tend to call routes on a server, right, what you often need to do is pass some kind of token or header that identifies you. It's like, it's like a hall pass. It's how someone knows that it's actually you asking for this and not a stranger. Because when you say to a server, hey, can I create a channel? A server's got to figure out who the hell you are, because maybe you're a stranger who's not allowed to do this kind of thing. How do they know who you are and what you're allowed to do? Well, you need some kind of identifier. So the register route is about give us the details of a person, we'll register them, and then we'll give you a token. So what's really cool about this doc thing, and this is a Swagger doc system, is that it shows you what information you need to send to the server, and then it shows you the kind of information you get back. So you can see here it actually says, okay, you send this information to the server, email, password, name. The server sends back a token, and it sends back a user ID as well. Okay, that's good. That's how you can figure out what user just registered, and the token to call the necessary next routes. And if there's an error, remember 400 responses are errors, you get told invalid input. So when it comes to HTTP requests that succeed, return a status code of 200. Requests that fail, return a status code of 400. That's kind of that. So then you have all these other routes, different things, get channels, blah, blah. Now, this room feels really dark. What we're going to do now is we're going to try and get a very simple web page together that lets us register someone, just so we can get a feel for it. So I've cloned that repository. I've got my server running. I'm going to open up another terminal. And now I'm going to go inside the front end folder. Okay. If I go back to the spec, there's some more stuff about the back end we can look at soon, but for now, that's fine. The front end says stub code's been provided to you in these files. Okay, so there's some stub code. You can modify or delete the stub code. It's just here to help. to work with your front end locally, you can run these commands. So let's run them. So let's actually try and get this front end up before we even look at the code. npm install -- global HTTP server. Now, we already had someone on the forum ask, why do we need this HTTP server? Why can't we just load our... wants to be sudo. To be honest, I don't even know if you need to... Do you need to do that? Let me try and skip this part. Maybe that step is not 100% necessary. No, it's not. Oh, maybe... you don't need the global thing. You might not even need to run that line at all. Give it a try. Every system is going to be different. Depends what you've installed previously. Depends what your permissions are. But the point is that this command here is actually what starts a web server. So this essentially starts for you a basic web server, and all that server does is serve static files in a given folder. Now, the one confusing thing here that I think might mess with some students is that you see it says npx http server frontend -p and then a port number. That port number is not your backend's port number, because the way these systems work is not... the way this system works is that your backend is a server running over here, and then your front end are files that a server exists for to serve those files. So there's actually kind of two actual servers running, one to just give your front end files to someone asking for it, and one to actually do the complex stuff on the back end. So you can kind of give a different port here, like 3000. So now you've got a server running on port 5005, and you've got a back end running on a port 5005, and you've got a front end running on port 3000. But let's go and actually have a look at these files. So I'm just going to open up my text editor. Let me just close off a whole bunch of other files I had. Oh my god, so much crap. Okay. Paul says VS Code's live server extension's the same as this. I think so, yes. It should be. I mean, the only reason this matters is actually to get around the CORS issues, the CORS issues. So you could actually kind of skip these instructions and just load the files manually until you run into problems. Like, and I'll show you what I mean by that. So like, I'm just gonna... Live servers has some issues that I think you can configure out. I haven't used it much myself. But the thing is, right, I've got my folder here for assignment 2 with my front end and my back end. And if I go in my front end folder, you can actually see I've got this like index, styles, I've got source. These are where all my files are. And if I just grab my index.html and I drag it up here, the page works. Like, it works. I don't need to run any server or whatever. But depending on your browser, depending on a few other things, which I don't think is worth getting into right now, sometimes it will cause your requests to fail. You'll notice that because if you open up the console, you'll actually... Well, it's actually happening right now. So... yeah. Okay, well, it's happening right now. You can see it's got all these random errors here that's like, access to this script from origin null has been blocked. But basically, your web browser is crapping its pants because you are trying to make requests to other pages when you are not a website. Like, it's like a file on a computer, and you're not an actual website. You're not an actual like web page on a server or anything. So I'm really simplifying that, but that's why it's angry, and this can cause some issues. I think Firefox doesn't care sometimes, Chrome cares, I can't remember, but to get around all the babble of it, we just say, well, instead of loading the file directly like that, you can actually run this server here, and what that does is that actually just, instead of you loading the files locally, it just quite literally means that if you go to localhost 3000, it will just serve those files for you. So if I go to localhost 3000, what's your problem? Am I in the right folder? Oh, maybe it wants me to do this. Sorry. Ooh, is that wrong in the spec? No, I've done something wrong. Why can't that be found? Oh, does it? Oh, okay, sure. No, alright, I'm running out of ideas. I'm not actually sure why that's not working. That's very weird. Simon 2 front end. Anyone have any ideas? This one stumped me a little bit. Why would that not be working? Did I not specify the right? Oh, sorry. Okay, I figured it out. Okay, yeah, thank you. Paul's figured it out. So basically, I was running that in the wrong folder. So the way this works is npx says, you know, go and get a module, HTTP server, and execute it. The first argument I'm going to give you is the folder to run the server in. So it's like, this is when you run the server, this is the folder that it's giving you files from, and then you give it the port. So either I could go back a folder and run this command, which is now mean it's going to run in the front end folder, or alternatively, if you want to, in the front end folder, instead of saying front end, you could just say // to mean this folder, whichever one works for you. I'm going to do this because it's the folder I was in. This should work now. And you can see now if I open up the console, I don't really have these errors like I do here. And you know, George has mentioned this before. It's like the whole thing is that when you have a web page that loads, it tries to get stuff from other web pages, either CSS imports, JavaScript fetch, like tons of different things. And if it notices that the stuff you're getting comes from a different website, sometimes it kind of, for security reasons, stops that happening. The problem with running files locally, like this, is that when it goes, which website is this coming from? It's like, it isn't a website. And you can actually see this here. It's like, from origin null. So this is actually it saying, where this, like, the page that's requesting this information, what website's it from? And the browser's like, nothing. And then it's like, oh, well, not doing it then. So it's a little bit of a security precaution, you know, and if that's not making sense to you, my point is when you go to google.com, you load this web page, but then the web page itself goes to load other things. And, you know, you can see this when you go to it. For instance, you just loaded the google.com page, but then it wants to load this page. So it pulls that in. And it's that actual kind of your web page interacting with other web URLs that is where this precaution kicks in. So that's why we run things in this little web server. Okay, I've got a simple page here. Great. Let's open this up. I'm just going to open this up in my editor. Okay, so we've got this is our simple web page here. I might make this super small and super duper small so we can get lots of space for our editor and have a little look at it. Perfect. Great. Now, what's the first thing we might want to do here? Well, the first thing we might want to do is try and call the register API. You look at this page, we've got a head here, some stuff, a title, some meta, some links. Okay, so it's including a style sheet. It's including another JavaScript file. And we have another JavaScript file being included down here. Now, again, remember, you could delete all of this if you want to. This is just some stub code for you. But in terms of the JavaScript code, we have two main files. One is helpers. This file is useful for taking a uploaded file and converting it to a base 64 encoded string, which you can figure out in the image types lecture. And then we have main.js, which is kind of where you can start writing some of your code if you want to, right? You know, so I'm going to start here because as you can see, main.js, it's imported from index.html. So it's like, all right, there's the beginning of my web page. So console log, let's go. I can see where that is. Great. Okay, cool. try some more. Console log test. Still works. No test. Okay, so why did it not work the first time? Some people have noticed this. I've seen on the forum as well. What web browsers do to improve efficiency? Sorry, I don't know why I'm fidgeting. What web browsers do to improve efficiency is that they cache certain files, and this is one of the benefits of an externally loaded script and stuff. So a web browser loads like all these different scripts and CSS files, and then when you go and load the exact same page, the web browser's like, oh, I already got all these. Don't worry, I've got them. We save time. Let's get the page up quicker. This is why you notice things like if I go to unsw.edu.au, right, here, and I refresh the page, I'm just going to do a normal refresh. Oh my god, look how slow it is. Still loading. Oh my god. If I just refresh the page, it's quick, right? Notice how quick that is? It's like, it's not that quick. It's quickish. Yeah, quickish. It's like really quick. And a big part of that is because when I go to the network tab over here, and I look at all the things that are being loaded, so I refresh this now, all these things are being loaded, right? You know, and it's happening super quick. But if I click on some of these things, and I'm just picking these randomly, this was not predetermined, you can actually see here that this particular JavaScript file, it says it loaded this from this URL, and it got it, but it's got this little note here that says from disk cache. So it's actually saying, actually, I didn't get this because I made a network request. I got this because I'd previously made one and I've stored it on the system for really, you know, so things are faster. And if you actually hold shift when you refresh the page, what that does is that forces your browser to clear the cache on that web page, I believe. And it'll actually go and refetch all of those things. So again, notice it's like click, refresh is like a second. If I then hold shift and I press that, it, depending on what the page, that took it slightly longer, but that one wasn't that dramatic. Yeah, it's like twice as, yeah, you can see it's a little bit slower, right? So this is me doing a shift refresh. So what's actually happening sometimes here is that when you're reloading this page, even though you add something, it's actually going and collecting an old version of the file. And you can see this in the network tab again. This is a very tangential lecture, but super interesting, I guess. When I refresh this page, and I look at main.js, which is the file I edited, it actually says from disk cache. So that's why if I went to the console log, it actually only prints let's go, even though I've got another file there. So what I need to do is, like, you know, there's other ways to get around this, but whenever I refresh, I mean, I refresh with Control R or Apple R, right? So I usually just do Control Shift R or Apple Shift R, which I think if you add shift, it kind of just forces the cache refresh. But you'll see if I do a Control Shift refresh or something, you can also disable the cache and all that too, though you can also disable it on the server, tons of different things. The only reason I'm pointing it out in this case is because it's a very useful keyboard command that most people aren't familiar with. So I refresh this page now, and you'll see that it will load this, but you'll see it won't have the from disk cache here. And when if I refresh the page without the cache clear, it says from memory cache. What's the difference between from memory cache and from disk cache? One's in RAM, one's in the hard drive. Like it's all just cached on your own system. Okay, so let's talk single page app, then let's get this registered JavaScript written. What is a single page app? A single page app is an application where you load the page once, and then every interaction you have after that does not consist of a full page reload. So let's think of it together. What's an example of a website? I'm just going to go to westpac.com.au. Ooh. That's interesting that Westpac haven't bought that. How can you tell what a single page app is? Well, one of the easiest ways in a more touchy-feely sense is that if you do things, if you watch up the top here, you'll actually see the reload thing happen, and you'll actually kind of see that the whole page nearly reloads, right? See how every time I click like a new thing, it's as if I'm making a whole new request and getting a whole new page back. And this is how the internet functioned for 25 years, right? It's like a long time. That's totally normal. It's a very simple way to do things. And the way these kinds of websites are set up is they're quite literally just a series of HTML pages, lots of different HTML pages that are all linked together. So, I click on board of directors, hey, John, Peter. This is super interesting. Corporate, whatever. It's all different things. Whereas if you think about what a single page app is, what a single page app does is the page loads, but any kind of change in what you see, whether it's a pop-up or whether it's a different screen, I call it, it all happens because of JavaScript. It all happens because of DOM manipulation. So you never actually refresh the whole page. You're actually just hiding things, showing things, popping things up over one another. And an example of a website that might do that, what's an example? I didn't think about this before the lecture. What's an example of a simple public site that would, Airbnb maybe? I know Airbnb, I mean, they contribute towards React, but if anyone has any other examples, feel free to share. So you notice about Airbnb is when I click on experiences, when I click on this one's a little bit more complicated, but Google Docs, React site, this is a React site. When I click on, when I go back to places to stay and I click on this one here, you'll notice that the actual website is changing, but it's not actually refreshing the page. And again, you can see this easily by looking at the little Airbnb logo up here. When I click on that one's opening it in a new tab for me, right? But it's like every time I do stuff, it's all actually on the same page load. So it's like a web server gives you this big file with all this JavaScript in it, and then once it's loaded, it all just kind of happens client side, right? So all these things just kind of happen. There's no full page refresh. And it's like how pages get that dynamic element is that while they're doing all these things client side, they're making little secret, quiet HTTP requests to the server to get more information. Simon did a bunch of lectures on this kind of stuff, and it's like, why did this come about? It came about because there was a desire to make websites feel more like apps. Like, this is one of the early stages of why web has been so dominant, because again, you think about an application on your computer, it's super quick, it's super fast. You don't have to like reload the screen every time you click on something else, right? It's much more responsive. So this kind of single page application like Airbnb here, where when I click on things and I click on this, in this case it's loading a whole different page, you can tell. This is actually a whole separate load, but people mentioned Google Docs as well. Google Docs is a single SPA, single page application. It's really just where the page loads once and there's no subsequent load. And it's like, people ask when I say that, most of you kind of get it. I feel this with students. You're like, yeah, okay, yeah, I get DOM manipulation. But then you're like, how do you do multi-page stuff? Because you get DOM manipulation as a pop-up, you hide something, you show something. And honestly, in the vanilla JavaScript sense, the stuff we're working with, most of it is truly just hiding and showing things. So like, I'll give you a really crude example here just to demonstrate the point. I've got this Slacker app, right? And let's say here, I'm going to create a nav bar. Is it nav? Yeah, nav bar. And inside that nav bar is just going to be, say, two things, just like home and about, right? Home and about, like this. And what I'm going to do is I'm going to go and create two divs. I'll call one page-home. Welcome to the home page. And I'll call one page-about, which is like welcome to the about page. All right. And these are both going to appear like this by default, but I only want one to show because I only want to be on the home page. So I might say, style equals display none here or something like this. Okay. Well, then how do I toggle between these pages? Well, exactly as you'd expect, you'd pretty much come here and you'd say, well, I've actually got these two little navbar options. Maybe I'll say this one is like page toggle home span, and I've got like a page toggle about. And then here, if someone clicks on home, you want to toggle a certain behavior. You want to have a certain action, which is to hide or show something. And if someone clicks about, you want to hide or show something. So in my main.js here, I just go and create like, document.getElement by ID, page toggle home, dot add event listener, click. And on that click, like, what are we going to do? I'll make this full screen here. On that click, what are we going to do? Well, we're just going to like literally document.getElement by ID, page home, style.display equals block, and then we'll hide about. So page about is going to be hidden. And if someone clicks on the page toggle about button, right, then we're going to do it the other way around. We're going to show about and hide home. And then I've got this page here where when I click about, nothing happens. Do I have to hard refresh? Is that the... Yeah. Now these should probably be links or something, or buttons, whatever, doesn't really matter. But like, we've essentially created a multi-page web page now. It's just that all the pages are kind of in one page. No one needs to know that though. Like, don't tell our customers, not that they care, but like, that's what a single page app is. The benefit of this too is that it's all one big life cycle. Like, the page is loaded, you have all your variables there, you don't need to think about what happens when it loads again. Now, one of the questions that kind of always comes to people's mind is like, all right, maybe I get this, Hayden, but how do I start on the about page? Like, how do I link someone to the about page? The answer to that question is, it's not that straightforward. There's a lot to do there, and in fact, we don't even ask you to do that for this assignment. There is like the advanced feature with the routing stuff, which kind of tackles this, but with React and other kind of declarative frameworks, this is much easier. With vanilla JavaScript, it's a little bit harder because you often have to kind of build out your own little bits of systems. But the short answer is, this is how you build a single page app, is that your app is going to consist of a series of pages, or what I call in the spec screens. The reason I say screens is because sometimes a screen is a full screen thing. Sometimes it's a pop-up. It doesn't really matter. Like, you can think about it as pages if you want, but these are two different screens, the home screen and the about screen. And you can toggle what's visible by playing around with DOM elements. So that's what a single page app is. Before I move on to the register route, does anyone have any questions about single page apps? Because that's obviously a very important thing. Cool. I'll give you 5 more seconds. Is it possible to link multiple CSS files? Yeah, you just include multiple CSS files in your header. You just put more up here. Definitely. You just put more there. Though, in general, all of, like, because it's a single page app, like, everything, like, the page will have all the CSS on it. Single page apps are slower to load than classic websites, but they're much more responsive to interact with. It's probably just my final point on this. So, if you do have these sites like Airbnb and stuff, it's like, yeah, okay, these are pretty like good sites, but they're really quite like loading them is quite a chunky thing compared to some really good static sites. Like, I don't know, Microsoft.com or something. Once the server connects, I don't know. I don't have an example for you, but so slow. Web's not that simple. It's not just like because it's a single page app, it's slow. It's not that simple. Sometimes they can be really quick. That's a whole topic, which we won't go into right now. Is having multiple JavaScript files going to make it too slow? No, multiple JavaScript files are fine. Yeah. Musa says, wouldn't the HTML page have many lines of code? What other efficient method is there to do this? The HTML page would have a lot of lines of code, and if it doesn't, it's because your JavaScript has a lot of lines of code. Remember, you could build a website that's quite literally nothing. Like, you could build a website that's just that, and you could construct everything with JavaScript, right? Like, that could be your HTML page, nothing, essentially. But then go and build it dynamically. The problem with that is that that's hard. And in fact, that's kind of what React does actually, is that like when you build these pages with React, it actually, that's why when you load a React app, it's often really tiny. Like in 1531, we have our leaderboard for groups. Oh, God damn it. CSE, they're making it so hard for me. It's like in 1531 we have this leaderboard for like their work. And this is a React app. This was built in React, right? And if you actually look at the source code and you click line wrap, you can actually see that there's like no HTML on this page, right? It's like, where's the body? It's like body's there and there's like a bunch of stuff and then it's just, here's a few JavaScript files. So this HTML is actually remarkably small because with these applications, the entire page is generated dynamically with JavaScript. You could do that. You could do that for the assignment, but you won't want to because that's tiring. Which do you think is easier? Constructing like a few elements with like this? Or is it easier to build it all? Like, is it easier to just write it in HTML or is it easier to make it in JavaScript? It's like, probably HTML. And in fact, that's what we did last week in week 3, and that's why I did that. Remember how we did the template thing? How we had like an email box template? That's a lot of what you're probably going to do in your assignment. Is like you'll kind of create templates in your HTML code so that you can use your JavaScript to easily kind of copy and paste them or you know, create many instances of them, right? So it's a little bit of a tango. It's a little bit of a tango between using JavaScript and using HTML and stuff. But largely, the reason you put stuff in the HTML is because you go, CBF writing it from generating this with JavaScript. That's why it'll be that's why it'll be in the HTML. Okie dokie. So let's get the register route together. Let's make a basic form and try this out. Really basic form. Let's just put this on the home page because we've already got this page here. I'm going to create an input type equals text. Let's just do this quickly. ID equals email. We'll do the same thing for, was it password? And I think they want the name as well, don't they? ID equals name and ID equals password. And we'll do input type equals password. But I'll leave this as text so you can see what I'm writing, because, you know, it's a lecture. And then we'll have a button for the submit. So, you know, a button, register, and button. And I'll give the, you know, it can be register or something. So we've got our basic HTML. We probably don't need to do much more than that. I'll copy and paste this into our JavaScript for now, just so you can actually, like, see what I wrote. Like this. We got that there. But let's actually write the JavaScript now. So what do we want to do? When someone clicks register, we want to get all the inputs. Okay, well, let's start off with that. Document get element by ID register dot add event listener on click. We will collect the stuff. So const email equals document dot get element by ID email dot value, because that's what we care about. We got the same thing for password, and then we're going to have the exact same thing for name. Now, I think it's name. I don't remember what the register route wants. So I'm going to go back and I'm going to have a look at the Swagger docs. Now, I might drag this out here so it's a bit bigger. The Swagger docs say for register that we want email, password, name. Great. Got it. Doing a good job so far. Cool. Let's try that out. Let's console log these things, right? So I want to console log these 3 things. Console.log that, and that. Load this page up. We got a form ABC, register, ABC. Okay, so we've captured it. Now the fun part is sending it to the server. So we know that the server's running on port 5005, right? We've seen that because, you know, we've loaded it up. How do we make a request to the server? Well, again, I'm assuming that you've gone and watched the lecture on promises and fetch, so I'll just try and run through it now. Now, I won't lie, I intentionally have not looked at fetch for a few months because I'm like, it's fun to figure some stuff out with you. What do we know about fetch? Well, what fetch is a function that sends information to an HTTP URL. It sends information to a URL and it gets something back. Okay. Well, what's the structure of fetch? You're probably going to forget sometimes. You know, that's normal. Fetch JavaScript. You could call it the fetch API. There's a bunch of different links. You could look at this random website and it'll show you the basics of it. It's like, all right, well, fetch takes in a URL and a series of options, and then it returns a promise. Okay, well, we can start with that. Const return promise. Call it that for now. Fetch URL. What URL are we going to do? Well, we're going to do localhost 5005. And then the options, well, I don't know what options. So let's leave that empty for now as an empty object. And let's just see what happens. Okay, refresh the page. ABC. Register. I didn't do a hard refresh, or I didn't disable the cache. You can disable the cache. You can do tons of stuff. Or did I? Oh, okay, I haven't console logged anything. I don't know if that worked or not. Now, how do you tell if that worked? You can open up the network tab and take a look at these things too. You'll find the network tab is extremely useful in this assignment. So for instance, if I open the network tab here, and I go ABC and I click register, you'll actually, is this it? Did that work? Yeah, okay, it did work. So what happened here was that I called this and it said it had a problem. It was like not found something, something, something. So I can see that the network request was made, but it didn't behave how I wanted it to. Now, the thing about network requests and stuff is that you're not just trying to connect the server, right? This isn't some connect thing. This is a literal go to this URL. And the thing is that if you go look at the backend pages, that URL is actually /auth/register. So here I'm actually interested in calling /auth/register. And what I'm also going to do is I'm going to print out the return promise, and we can just have a look at what it is. So we go back to our page, we'll refresh the page, ABC, I click register. Okay, and I get a 404 now. It says 404 not found. Wonder why that is. Server seems to be running on port 5005. Does anyone have any ideas what's gone wrong here? I'm sure someone has an inkling what's gone wrong. Server should be running. Localhost 5005. I'm calling the right auth/register. Yeah, so Nilnako says no get, use post. So remember that when it comes to basic HTTP routing, there's the 4 different types of HTTP methods, right? You got get, post, put, and delete. Now, these are all just semantic. They don't mean anything technically. But when you define them on a server, it is actually relevant what you do here. So I'm going to now say, you know, fetch post request. Because when you do a fetch, just like a web browser, will automatically make a get request. So if you don't specify it, it'll do a get request. And if we have a look at an example here, you can actually see in this particular example that this fetch, right, it's going to this URL and then it's giving it the request options. And you can actually see there's a few options being used here. And funnily enough, we're actually interested in all of these options in this case. So I'm going to copy and paste this one. This isn't plagiarism. This is just basic code, right? So what's actually happening here is that I want to call Auth Register, but the options, as in these are like the parameters of the function, right? I want my method to be post because it's a post request. I want my headers to say content type is application/JSON. Now this line I'm pretty sure is necessary because the way the server is set up is it expects JSON packets from the front end. So you need to send your stuff from the front end as a JSON packet, and the body of the request, the body of the post request needs to be JSON as well. So you can see here this JSON stringify, it's taking this JavaScript object and turning it into a JSON string. Now I might just extract this out for you as well and say const JSON string. Oh, my phone credits will expire tonight. Okay, JSON string there, and then I'll say console.log JSON string. So we can actually have a look at what it is, right? But we've got these request options here. So now this fetch is going to that, and it's sending it with these options. And you know, let's see what it does. Let's see what it does. Refresh, A, B, C, send. Ooh, this is good. 200's a good number. 200 means success. What happened here? It seemed to succeed. It shouldn't have, though. Ooh. That's weird. By the way, this is a whole new assignment we've written from scratch. So occasionally you will come across the odd thing in it, and we'll help fix it up. This is inevitable with whole new complex assignments. I'm not sure if this is one of them, because this is the first time I really use this backend, but we'll see. This shouldn't have worked because we're sending it the wrong information, right? We should be getting a 400, but let's check it out. So the JSON string you can see here that we sent to the server was this piece of text, right? We don't want to send that piece of text. We want to send a piece of text that works for the Auth Register route. So we want to send like email, password, name. So let's actually construct that together here. So instead of this JSON stringify title, because like who cares what that is, let's just do email. The email key is the email property, the password key is the password property, and the name key is the name property. And like what's helpful here, remember that with JavaScript too, if you're using an object like this, and you're saying key is value, key is variable. If these two things are the same, you can actually, in shorthand, just do that. It's a little bit of a weird syntax. I like it, I use it, but I won't put it here, but you can actually shorten that down if you're literally repeating yourself like this. So we're saying, here's an object with an email, password, name key that has these values, which we've pulled out from the DOM elements, their value properties from the inputs. That object stringified into JSON, and then we're going to send that to the server. So now when I refresh this page and I do ABC and I register, you'll actually see this is what we're sending to the server. Cool. Okay, so that all seems to be pretty okay. So we've now sent that request. That one probably seemed to succeed as well. The last kind of piece of the puzzle here is what you know, how do we get the stuff from the request, right? Like, how do we actually get the payload? Because remember, what this should do is this should return us something like this with a token and user ID. Okay, well, now we have to think about promises. So the way promises work, which again, you can go watch the promises lecture, is that quite often, if you take a promise like return promise and you try and console log it, what you get is what we saw before, where it just says pending, promise pending. Now this is because promises are the foundation of JavaScript's asynchronicity, because in JavaScript, most things don't just happen kind of like imperatively, like one after another. Sometimes we go to do something and JavaScript will keep executing and it will eventually finish it off. And that's what's happening here. So that's why we need to use the syntax with JavaScript. We have return promise dot then, and what you give the dot then is a function. So let's say like I'll just show you what I mean here. Let's create a function called do something, and all it's going to do is console.log 1 like this, and then I'm going to console.log 2 here, and then I'm going to just pass in do something as a function here. So what should happen is that we make this fetch. We pass in those options. When the fetch is done, we call the function do something, which should console log 1. And then after that, we console log 2. But if I refresh this page and I go ABC, you'll actually see it printed out 2 and then it printed out 1. And it did that in that order because the JavaScript code will not stop and wait for this fetch to finish, because fetch does not block. This is true for network requests, file system openings, and a whole bunch of other things. And it's one of the better parts of some of, I guess, these languages compared to things like Python or whatever. So it's like this fetch here will start executing, and it'll queue something, and then the code will just keep running, and then when it's done, it'll trigger this little line here. This is one of the harder parts of the course, to be honest, and this is explained in other lectures, and we can talk about it next week. We can talk about it the week after. Next week's largely going to be like an assignment to help session in a lecture time. But also typically you won't actually write your promises like this. You'll actually just write them straight like this, because this is actually kind of easier to read. It's like, do the fetch, which is asynchronous, so it's going to go away and quietly do something in the background, and when that's done, call this function do something. So fetch is called, starts executing, background, it continues on, we console log 2, we console log 3, and then eventually when it's done, we console log 1. And again, if you watch it again, you'll see it happens pretty quick. But yeah, 2, 3, 1, like that. That's what it did there, 2, 3, 1. Because this took a tenth of a second to process, or whatever it is. So what do you actually do here? Well, it then takes in a function, but you don't need to create a whole new function. You can just do what we've been doing in the tutes and the lectures. You can just make a function like this, inline, console.log1. Even better, nice and easy, nice and concise, right? So we fetch that. When it's done, it's going to call this function, ABC. Yep, so that worked. By the way, pro tip, if you're ever doing testing like this, just start putting real values in your HTML whilst you're testing. It will make your life substantially easier, because now you don't have to enter everything, right? So it's like, okay, register, refresh, register. So you can see that's working, but when a promise returns, there's actually some information associated with it, and we're going to capture that. We're going to just capture that in this variable called data, and that's what we're going to console log here. Okay, and what it's giving us here is a whole error. It's giving us, it's blah, 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 status code 400. That tells us that something went wrong, bad request, and so forth. So I can actually start doing some, conditional stuff here, like if data.status equals 400, alert, bad input or something, else if data.status equals 200, console.log, all worked. Now, does the server provide useful errors that you have to pass on to the user? Not really. The main thing we care about is that an error that occurs on the server is communicated to the user. You could obviously write nice errors here. Please enter valid details or something like that. So now you'll see when I refresh this page and I click register, I get this pop-up alert here because the status code was 400. But what happens if I provide valid details? Right, Hayden at unsw.edu.au. I like dogs. Hayden, try that, register. It worked. In both of these cases, we sent a request to the server. The server responded with a 400 the first time, and the second time it succeeded, and it sent me back some data. What it sent me back, I didn't actually print out the data. Whoops. So I need to print out the data too, because I want to see what it gave me, because I'm interested in it. So console.log data. Okay, so refresh. I should probably hard code these. Hayden at unsw.edu.au. I like dogs. Hayden, register. Please enter valid details. Why is this failed here? This is failed because this is a register route. And just because we refreshed our web page, it doesn't mean that our server's refreshed, because the server now has that email in it. How do we get around this? Well, one thing we could do is we could change the email we use. That now works. So it says it worked, and I can look at the body that I get back. Now here's the tricky part here. The body that I get back here is actually JSON, and this is just kind of like a little tip here. Because the body that I've got back from that request is JSON, what I actually have to do is decode that JSON again. And this is where things also get a bit weird, is that I think I have to say here data.json like this, and this is built into fetch, where if you just get the response object, and to be honest with you, normally you wouldn't call this data, normally you would call this one response. When you get the response object and you call .json on it, that's actually a function that says extract from the body of the response the JSON, extract from the body of the response, which is JSON, what I'm looking for. But here's the problem again. If I said something like console.log response.json, you'll see what will happen here. Hayden 3. I'm watching the time too. Password I like dogs. Name Hayden. It works, but when I console log it, I get a promise. And if you ever console log something and it says promise, it means you need to treat it like a promise. You can't just treat it like a standard imperative variable where you're like, oh yeah, I'm just going to print out what that is. So I have to do the same thing here. Response.json is a promise, which means it has some delayed execution. So to get a reaction from it, I have to do dot then, and then pass in a function. And this will actually probably return me the data. And then here, console.log data. So this is actually kind of like a promise within a promise kind of thing here. And again, we'll do this one more time. Hayden 4 at unsw.edu.au. I like dogs. Hayden, run it. There's my token. There's my user ID. Great. I have that information from the server now. If I get that information, what can I do? I could maybe hide this register form and display the list of channels. Right? Like this is where you start to get back into the DOM manipulation. So, you know, you actually have all of the foundational knowledge to do a lot from here easily. It's like pretty straightforward. Vilnaco says, is it okay to use local storage for the token? Yeah, definitely. You can use local storage for the token. Yeah. Yeah, it's fine. Samir says, with the data you get back, do you need to use promises every time you want to use that data? No. The promises are a way of dealing with asynchronous programming, because here's what you would do in a normal language, right? If you were normal language in another language, in a language like Python, right? So Python is single-threaded by default. JavaScript is multi-threaded by default. They could both do the other way around. But JavaScript just has a default. So in Python, you'd say something like, you know, and you can do this in JavaScript too separately, is you could say, you know, like response equals fetch this. Now this is invalid JavaScript, but I'm just trying to demonstrate a point. Response is that, you know, if response.status is 400, then do that. Else, say data equals response.json. Console.log data. Now you might look at this and think, well, that looks a hell of a lot nicer, doesn't it? The problem with this though is that this would block execution. So let's say you had to render something after this. It literally freezes the code right there. Does not continue executing. That might take a half second or a 1 second. So once you start getting into more complex applications and you have things you want to render, if everything you did was blocking, the page would lag. The page would appear to freeze for a couple seconds because everything would be stuck on a stupid file or network or some other kind of request. So asynchronicity is extremely powerful, and in a lot of ways it's nearly necessary for what we're trying to do, which is interactive, responsive web pages. So embrace it as a way to solve a problem. We'll talk later about, you know, you can write these things differently, blah, 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 but Selena says, so after you register, where will the email address be stored? Email address, name, password. Well, I mean, it's stored in the server. We'll probably run to like 803, by the way, I'm guessing. So it's stored in the server. In fact, you can actually see this, and what I was going to show you before is that this is the backend running here. If I stop the backend running, the website won't work. But there's actually a file here called database.json, and if I open it, this is actually the server. It's storing all of the things we've been inputting. We actually left you with some stub data. That's nice of us. I feel like there might be a bug here, because I don't think it should have registered these users. Maybe it doesn't check. Actually, maybe I don't even, you know what? I don't think it's a bug. I think that we just expect you to do that kind of checking. In fact, I don't even know if we ask you to do that kind of checking. Yeah, I don't even think we ask you to do that kind of checking. There you go. I mean, it's not critical. Like, this is an educational assignment. So, yeah. That's okay. It's not a bug though. Don't freak out. It's just like we just don't check that because. By the way, just to be clear, the reason we don't check that is because I have a philosophy that I'll write as little code as I can that we give to you, because the more code we write, the more likely it is to break. You know what I mean? So it's like by not having all of our server-side checks give to you, it's like a whole new assignment. It's just the simpler, the better, the less headaches you have. If you want to check it, which is probably good practice anyway, you just do it front end. In reality, obviously you have server-side checks because front end is totally vulnerable to attacks, but you know, the priority of this isn't for you to validate email addresses. The priority for you is to understand the whole ecosystem. But anyway, my point is, what happens if you don't like what happens if you want to reset this? In the backend folder, you can just run yarn reset, and that will actually delete your database and totally reset it. And then if you open it again, it's got the stub data again. So we actually do give you the stub data. Emily's been very kind to help generate a whole bunch of fake messages and fake channels. And you can actually go and look at this, right? You can literally go and look at this and see what the emails are and the passwords are and test with it. You could actually start with the login and not with the register. You know, register can come later. That's totally up to you. Maybe not. Wilhelm says, can we use our old Slacker backend? Probably not, because the API is different. We could have stolen a student's one, but I don't like web servers written in Python. I think JavaScript's pretty elegant for web servers. Okay. I feel like the only unanswered question there is what happens after people log in, which I kind of answered before, but just to reiterate, once they log in, once you get to this point here and you have something valid, you could change the page, hide the register screen, show our, you know, show the channels screen. When you refresh the page, you'll probably be logged out again and you have to log in. So it's all fine. This is the gist of it. Like, if you can get over this hurdle that I just showed you, then a lot of the assignment, there will be challenges. You'll have to figure things out. You'll have to read more and all this, but it's all roughly the same thing, right? It's all generally on the same path of what we've gone through today. That's kind of the point of going through it today. Lil Nako says, is it better to store it in local storage or a local variable? Because it's a single page app, it doesn't really matter. The only benefit of storing in local storage is if you refresh the page, you might not have to log in again. But that can be solved just by storing the access token too, right? That can be totally solved. Yeah, it's okay to do that, Raymond. So last thing, I will actually just kill a few minutes. I hate going overtime with lectures, but I know we started late because of the technical issues, and I'll just spend a few minutes on this because it just occurred to me that it's probably quite useful. Is once you have that token, how do you call another route? So as you've seen here, I got my token response back. When I got it back, I got this thing here that said token, and it was that. It's like, okay, cool. Well, what happens if I want to take that and then make another request to get like the channels or something? So what I'll do, and I'm just going to do this randomly, is like I'll make a function called like get channels, and it can take in a token, sure. And then all I'm going to do is once I get my data back from my successful login, I'm just going to call get channels with data token, right? Because the token is what you need to make subsequent requests. So this is, I think, maybe the only missing hole in your knowledge at this point, probably, is like, okay, so you've logged in, great. How do you make more requests? Well, now that I've got my token, I'm just going to call this get channels function. And you know what I'm going to do? I'm going to make another fetch. Except this time I'm going to get the channels. And the channels, if I scroll further down, get a list of all the channels, it's a slash channel with a get. So now I'll simply in this one say, you know, slash channel. Channel. The request options in this case, I'll just write them in myself. Method can be get. Headers can be content type as that, sure. And what does it actually take in? Well, the thing about get channels is that it actually doesn't take in a body. But what it does do is it takes in a header. So for most of your requests that aren't login or register, whether or not you have a body, you're going to have in your header not just the content type, but you're also going to have a particular field which says, it's written here, authorization. Then it's going to say bearer, and then the token. Now, what in the world is this? This is part of OAuth standard. This is kind of just like standard authentication practices, but this is like how you get your subsequent request to know it's valid, because this is how you give it a token. Now, I probably made a small mistake here, but regardless, let's try and see the response we get. I'll just quickly do this here. I'll say, well, response.json.then data console log.data. So if I've done this correctly, what will happen is that after I log in, when all that's done, I call my getChannels function, which makes another fetch that calls the channel. Once it's done, I get the response. I do the JSON decoding. Once it's done, I console log it. And let's see what this gets for us. There's quite a lot of moving parts here, so there's probably going to be a problem. We can just do ABC though. Ah, the server's off. Nearly there, guys. We'll be done soon. I mean, you can leave. I'm here because I think you want this. So I don't know. Sorry, not sorry. Okay, so oh, it worked. Getting lucky. So yeah, it literally did that. It called getChannels, which made another fetch. You can see this in the network tab too. So if I open up the network tab, where's the button to do that? Is it hiding? Screen's so small. Oh, there it is. Network. You can see that we called register and then we called channel. So we actually made two like fetches in that case. And it returned as channels, which is an array, and inside that is an array with an object, and there's the channel creator, user ID, the ID of the channel, the ID of the members in the channel, the name of the channel, whether the channel is private or not. So again, the reason I wanted to show you this is like, the point is you can make kind of multiple fetches. It's all doable. There's some challenges. It might take some of you some time as you're like building up, but you know, that's why I wanted to talk about this today. So you come away from this and you say, I know what to do, and start the assignment too. I hope you're not watching this like 3 days before it's due, but like, you know, it's so manageable if you just start tomorrow and you do a bit more on the weekend, and then you do a bit more. Like if you just chip away at it, it's very manageable. It's really tough. I've seen this for 2 terms now. It's really tough if students, you kind of put it off because you're nervous, and then you kind of start it on the weekend at the end of week 5, and then like Thursday of flex week, you're like, all right, we're going to really get this done. I got 4 days. It's going to be a crappy 4 days. It's going to be an absolute crappy 4 days. So like, I'm here tonight to give you confidence to get going so that you do not have a miserable time. So do your best, you know, get going, and we're here to support you. I'll answer these last questions, then we'll finish because, you know, we're slightly over time. Just to clarify, we can do these on our laptop. Don't need to run these in CSEV Lab. Yeah, absolutely. All you need is Node and NPM. It runs like a treat. Pengyang, which means we need to store... Oh, Pengyang asked a big question. The multi-user, does that mean we can log in multi-tag pages, which means we need to store for each session? No. Don't worry about that multi-user word. That's just saying that you can register as a user, log in, do stuff, log out, register, like log in as another user, like standard application. And then Raymond says, so our entire SPA's page is going to basically be in promises. Yeah. It's, the whole assignment is like collectively organizing a single HTML page to be a dynamic thing held up by fetches, getting data, and just some intelligent DOM management, you know. Vanilla JavaScript is not the most elegant thing in the world. That's why we also teach React in this course, though we consider these skills fundamental, so that's why we're doing it. And it's very manageable if you start early, so yeah. Anyway, I think that's everything. I hope you all have a great evening for those watching live. For those watching later, I hope you're having a great whatever the hell you're up to today. I hope it's, you know, hope it's early enough for you to get started, but good luck with it. It's a lot of fun once you get settled, and you'll feel like you're really understanding promises and DOMs and how web pages are constructed, right? So it's a rewarding assignment, I think. Last two questions, literally. Raymond, is it okay to ask if we can make a JavaScript file for each page? Yes, one HTML file, many JavaScript files as you want. Kath, should we be structuring JavaScript files by functionalities? It's totally up to you. Tutors don't care about that. I don't even have great advice on it because, honestly, most people don't build websites like this anymore. It's a very old school way of doing it. So, by functionality is fine. I definitely break it up. We'll try and talk about that more next week. Thank you, everyone. Have a great evening. Look after yourselves. Stay safe. All of that. See you later.